Now let's start the chapter on brakes. And the very first video we'll look at is the single block or shoe brake. This is the schematic of a shoe brake. So you have a drum. This is called the drum. Okay. This is the shoe. This part. Shoe. This part is the shoe, which is pressing against the drum, which is rotating. This is the fulcrum, and this is the lever at which a force is acting in the downward direction, pressing the shoe against the drum and stopping it. Okay, so the length of the lever is B. Because this shoe is pressing against the drum like this, there will be an upward normal reaction from the drum onto the shoe, that is capital R. So if I look at it, this is how the system looks like. So this is P, this is R, okay, this is O. So this is a distance small a, and this distance is small b. Okay, small b, and this load is P. If I take moments about point P, you will have R into A going in anti-clockwise direction and P into B going in clockwise direction is equal to P into P. From this equation I can find out R, which will be P into B upon A. Because this drum is going in a clockwise direction, the peripheral velocity is going to be in this direction, tangentially. To oppose that, you will have a frictional force in this direction. Okay, so your frictional force is capital F, which is mu into the normal reaction R. We know the value of R, so we will write down mu into P into B upon small a. That's the value of frictional force. Now, the braking torque, this is TB, this is F into R, which is the radius of the drum. So this would be mu into PB upon A into R. This is the braking torque. Now let us say this drum is a wheel which is put on road and is moving. So the velocity of the drum, which is now moving on the road, is V. Okay, so let us say the drum moves with a velocity V. And we apply brake onto it. So the braking distance is, let us say, small s. So braking distance, the distance in which the velocity becomes 0 is called braking distance. So braking distance is, let us say, s. So the work done against the friction would be work done against friction. This is frictional force into the braking distance. So we'll have mu P into B into S upon A. That's the work done against friction. Now in this much frictional, I can say if there is friction, so there has to be some work done to overcome that friction. This will make the kinetic energy of this drum to be dissipated. So the kinetic energy lost should be equal to the work done against friction. That is by the law of conservation of energy against friction. So this would be 1 by 2 mv square plus I omega square is equal to mu into PBS upon A. So you can use this formula to calculate the required parameter in a single block or a shoe brake. So I hope you got this. Now in the next video, we'll look at the pivoted shoe brake.